In this video, we are going to solve the iris dataset with TensorFlow JS in Node.js. TensorFlow is, of course, Google's awesome machine learning neural network library, and we are going to use this for JavaScript now because they are actively developing a really great version of that for JavaScript. And it's still in development, but it's very much usable today. So here's the iris dataset in JSON format. If you're not familiar with it, it has 4 measurements for a variety of iris flowers, and then it determines from those what the species is. So we're going to take this dataset, train a neural network on it, and then we can give it any 4 measurements from any iris flower and ideally predict what the species is. So I've gone ahead and broken out also a few pieces of testing data. This is really important as well. So I've taken 3 items out of the data set and they only exist in this testing data set. So once we've trained our neural network, we can run these values through and hopefully get some responses that are correct and show that our network is trained properly. So let's go ahead and get started using TensorFlow JS. To get started, let's go ahead and define all of our imports. Okay, you can see that we've imported TF, that's our TensorFlow library. We've also just imported TF.js node. That's going to set some Node.js bindings that make it more performant. And then we've imported our 2 data sets. So now we can go ahead, let's do some comments here so we can actually kind of mentally think through what we're going to do. We're going to convert our data, and then we are going to test or build our network. We're going to train that network. And then we're going to test that network to make sure it actually performs well. That is all we're going to do. So let's start by converting our data real quick. So our data, as you can see here, is in object format. We need to convert this to input values and output values. And that's pretty simple to do. We basically want it to look like this. Our input values will be 4 arrays that have, our numbers. Let's just say those are our 4 measurements right there. And our output value will be a 3-dimension array because we have 3 different species in the iris dataset. We have Setosa, Virginica, and Versicolor. So this will say for Setosa, this will be 1, 0, 0. For Virginica, it will be 0, 1, 0, and so on. So we're basically going to convert this to flat arrays. And then we are going to wrap these in tf.tensor2d. And that's going to convert that into a format that TensorFlow loves. So to do that, let's go ahead and take our input data and we're going to map that. So we'll take our iris.map. We're going to iterate over that. Let's get an item here. And we're going to return an array here. So there's all our items. We're converting that item into a flat array, passing that whole array of arrays to TF Tensor 2D. So that's our training data. Let's go ahead and get our output data now. Our output data is the exact same thing, except for we are going to just basically say, is this Setosa? Let's make item 1 a 1. If it's Virginica, let's make the second item in the array a 1. And if it's Versicolor, let's make the third item in the array a 1. So we can do this by doing a simple ternary. If it's Setosa, let's make item 1 a 1. Otherwise, let's make it a 0. So let's copy and paste this 3 times. If it's Virginica, then it's the second item is going to be a 1. And if it's Versicolor, the third item will be a 1. So there we go. We've got our data set up. And let's do the exact same thing on training data for our testing data. So our testing data will be in the exact same format, except for we're not going to loop over all of iris. We're going to loop over iris testing. So now we're going to have how many items we're in testing? 3 items we're in testing. So this is a 3-item testing data array. So there we go. Our data is completely set up. Now we can actually build this neural network. It's slightly more hands-on than doing it in Brain.js, which we've done in our past videos, which is extraordinarily simple, but you also don't do any configuration. In TensorFlow, it's a little bit more manual because you add all the layers yourself. So let's start by creating our network, our model. So it's called tf.sequential. We're basically creating our sequential neural network. That is our model. That's our network. And now we can add layers to that. And we're going to add a tf layers dense. So we're going to add a dense layer. This dense layer is going to have an input shape of 4 because our data set has 4 items in the input. So those are our input dimensions. So it's going to be an array of 4. That's how we define that. Let's give it a sigmoid activation function. Why sigmoid? Sigmoid is good for classification problems where it's going to be a 1 or a 0 and it's classifying it into one of these 3 buckets. Classification, again, is when we have multiple output dimensions that are going to ideally be 1 or 0. Regression problems would be if we have a single output dimension that's like a score. We're scoring from 0 to 100. Other activation functions like ReLU are better for things like that. But sigmoid works really well for classification. So we're going to do the sigmoid activation function. And we're also going to say, hey, how many units are we putting out here? Let's put out 5. So we're going to put out 5. I just kind of picked a number out of the hat. There is our first layer. Let's add another layer now. Let's add a hidden layer. Input shape is going to be 5 because this one is kicking out to 5. This one is receiving 5. And then this one is going down to 3 units because our output is 3 units, our output layer. So then lastly, let's go ahead and add a final shape. It doesn't need input. Input can also be dynamically determined, so you don't really need that to happen. And there we go. We're good to go. We've added our 3 layers. Last thing we need to do is we need to add the error function and the error handling. How is it going to compute the error? There's multiple different functions and methods for backpropagation. So this is kind of a good standard for what we're going to do here. Let's go model.compile. Here's 2 good standards. We can do loss of mean squared error, and you can do an optimizer function of atom. You don't really have to understand how these are working. These are just a good set of defaults for you. And a good default for atom is 0.06. Again, don't have to fully understand that right now, but that's a good standard compile configuration. So now our network is complete. We can go ahead and train our network, which is called fitting in TensorFlow. So let's go ahead and save our start time here so we can see how long this takes. We got our start time saved, and we can go model.fit. Let's fit our information data into the neural network and our output data. And then how many times do we want to train? It's called epochs. Let's train 100 times. Let's just start there. So now we're going to receive a promise. So we can go .then. That's going to train asynchronously or synchronously, however you want to look at it. Then, and we'll also get this history here. Let's console log done. And date now minus start time. Let's save this and see what happens here. We've got this error. That's no big deal. It's training our network, done in 4 seconds. There we go. It's trained in about 4 seconds. So now let's go ahead and actually see what this history object looks like. Let's look at this history object and see what that says. Here is all the errors that we're getting. So if we scroll up, you can see we have our loss history. It starts up with a pretty big error number, and that error number gets smaller and smaller and smaller and smaller, a little bit of back and forth as it goes through all the iterations. You can see that we're sitting at about a 0.01 error level. So that should give us some pretty good results. Let's go ahead and test this now. So in this then function, after it's been trained, let's go ahead and kill that console log there. Let's go model.predict. We can do model.predict, and we can give it our testing data. And we can also then go .print. So it's going to train, and then it's going to run our testing data through the prediction. And you can see that our first piece of data, it thinks, pretty strongly that it's a, what are those? Setosa, Virginica, and Versicolor. You can see that our error is pretty small. We have trained successfully against the iris dataset. This should be 100, this should be 010, and this should be 001 because our testing data is Setosa, Virginica, Versicolor. So there we go. We have created a neural network. We've added 3 layers to it. We have trained it. And then once we're done, we have tested it to prove that it is working correctly. So there you have it. That is how you build a neural network in TensorFlow JS, train it, solve the iris dataset problem, and prove that you actually solved that problem correctly. I'm going to put this code on GitHub in a gist and add the link to that in the description. And that is all. Have yourself an excellent day.